Hi guys, welcome to TechNet Labs. Today we're going to be going over a variable length subnet mask, also known as VLSM. This is going to be a continuation from our previous lesson, which was basic subnetting. So if you haven't watched that, make sure you go back and check that video out first. And when you're done, come back to this video. So yeah, let's begin. So what is VLSM? So in short, VLSM is using different subnet masks for different subnets that you create. So if we use our example from our previous lesson, we had created 4 subnets. They were all the same size. And so the requirements were to have 20 hosts for each subnet, and it accommodates for 20 hosts each. So what VLSM does is that it allows us to have different hosts for each of our subnets. What VLSM allows us to do is to have different subnet masks for each of our subnets due to their requirements. So let's say the first subnet had 10, second one had 20, third one had 30 and 40. So since the requirements for each subnet would be different, subnet masks would be different. So in short, VLSM allows us to tailor our subnet mask to the requirements of each subnet. So that's what VLSM does. Okay, so the next question is, why do we use it? So we use it to increase the usage of our subnets. So for our first subnet, we required 20 hosts. And so after we use 20 hosts, that's from 1 to 20, we have another 10 remaining IP addresses which we are not using. So what VLSM does is it allows us to tailor each subnet to its exact requirements so that we're not wasting IP addresses. As soon as a subnetwork is done with using a network, say from 20, the next subnet will begin from where the previous subnet ends. So from 20, the next subnet would begin from after 20. So we wouldn't be wasting those 10 IP addresses. Okay guys, so here's our example. Here we have our network. We have the IP address 192.168.2.0/24. That is a class C address, and that can also be written as 255.255.255.0. That's the subnet mask. So the first thing that we need to understand when doing VLSM is that when we are assigning IP addresses for each of the subnets, we need to first of all look at the requirements for each subnet and start from the highest to lowest. The first thing is start from so if we look at each subnet, we have one subnet here, we have another one here, we have another one here, and then we also have a subnet here, and a subnet here, and another subnet here. So in total, we have 1, 2, 3, 4, 5, 6. We have 6 subnets. And so when we are assigning IP addresses, we start from the highest to the smallest. So in order, we start from 50, then we have 24, then we have 8, then we have 3 sets of 2s. The 2s for 2 hosts, this is known as a point-to-point connection. This is where each end has one IP address. So we'll get onto that later on. So our aim is to tailor each subnet to the requirements for the number of hosts. Okay, so just on this side, I'm going to write down the correlation between the number of host bits used and in turn how many IP addresses that we're going to get out of it. So if we borrow 1 bit, we're going to get 2. If we borrow 2 bits for host, we're going to have 4. Or 3, we're going to have 8. 4, we're going to have 16. If we borrow 5, we're going to have 32. If we're going to borrow 6, we have 64. And if we borrow 7 bits for the host, we're going to get 128. And if we borrow 8 bits, we're going to get 256. So we're going to start with our highest host requirements, so which is 50 hosts. And so we're going to look at this table here to find out how many host bits we're going to need to use in order to accommodate for the 50 hosts. And that's going to lie between here We cannot use 5 bits because that's too small. 32 hosts doesn't meet the 52 requirements. So we're going to go for the next highest, which is 64. So we're going to, for the last octet, which is usually, so the first 3 are going to be on. We're going to have 255, 255, 255. And so for the last octet, we're going to have 6 bits for the host and 2 bits for the network. So the network is going to be on, and dividing line is going to be here, and then 6 bits for the host. 1, 2, 3, 4, 5, 6. Okay, and so we need to find out the magic number for this case, which is going to be the first binary number from the left of the dividing line, and that is going to be 1, 2, 4, 8, 16, 32, 64. So this value here is 64, and that is going to be our next increment for our network. So we initially started with 192.168.2.0, and so the next subnet is going to begin from 192.168.2.64. And so we also need to find out the subnet mask for our first subnet, which is 255.255.255, and having the first 2 bits on, which is 128 plus 64, which is 192. Since we're borrowing 2 bits, it's going to be 24 from here, plus 2 bits, which is going to be 26, and the subnet mask will be 255.255.192. So that's the first network that we dealt with. The next largest is going to be 24 hosts. So where does 24 lie on this table? It's going to be between 16 and 32. We obviously can't go for 4 bits because that gives us 16-bit hosts, and so the next highest is going to be 32, so it lies between here. We're going to use 5 bits for a host and 3 bits for our network. So it's going to be 255, 255, 255, and then so we're going to have 3 bits for our network, and the dividing line is going to be, and the dividing line is going to be here, and we're going to have 5 bits for a host, 1, 2, 3, 4, 5. So we're going to find out our magic number, which is to the left of the dividing line. That's 1, 2, 4, 8, 16, 32. So it's going to be 32. For our next increment, for our next network, is going to be 192.168.2.64 plus 32, which is 96. So that's where our next network is going to begin. So we're just going to continue dealing with this. So our new subnet mask will be adding the values of the 3 bits to our subnet mask, which is going to be 128, 64, and 32. And so together that will be 255, 255, 255, and that's 192.224. Okay, so that's our new subnet mask. This can also be written as adding 3 bits to our original prefix, which is 24, plus 3, which is 27. Okay, so that's the second network dealt with. So the third network is going to be 8 hosts, which is the next largest. For our next network, it's going to be 8 hosts that we require. So if we look at the table, we have 3 bits for the host here, and it will give us exactly 8 IP addresses. However, this is including the network address and the broadcast address. So if you minus 2 from this number, you actually have 6 IP addresses, whereas we need 8. This goes for all of these values, where it includes the network address and the host address. So after we take out the network address and the broadcast address, we'd only be left with 6 addresses, and that doesn't meet our requirements. So we're going to actually have to go for our next highest, which is borrowing 4 bits, and it's going to be here. So that will give us 16 IP addresses. And so if we write that out, it's going to be 255, 255, 255. And so we're using 4 bits for the host, which means that we're going to have 4 bits for the network. So we're going to have 4 bits here, 1, 2, 3, 4, and then we're going to have our dividing line here, and then 4 bits for our host here. So now we need to find out the magic number, which is to the left of the dividing line. That's 1, 2, 4, 8, 16. So 16 is going to be our next increment for our next subnet. So adding on from this network, so it's going to be 192.168.2.96 plus 16, which is 112. Okay, and then the new subnet mask will be 255, 255, 255. And so adding up all the bits which are on, which is 128, 64, 32. So that's 240. That's 240. Okay, and this can also be written as 24 plus the 4 bits here, which is going to be /28. And so that's the subnet for 8 hosts. Okay, so now moving on to the final 3, which is these point-to-point connections. And this is where there are only 2 IP addresses for this network. So when we look back at our table for 2 hosts, we cannot choose this, because if we choose 1 bit for the host, we have 2 addresses here, and that also includes the network address and the broadcast address. So actually there will be no IP addresses for the actual points here. And so we need to go for the next highest. And so that will be borrowing 2 bits here. And so if we minus 2 from the network address and the broadcast address, we would still have 2 IP address left over for the 2 points here. And so therefore we're going to be borrowing 2. So the subnet will look a little bit like this. We have 255, 255, 255. So we're going to be borrowing, it's going to be here, we're going to be borrowing 2 bits, and we're going to have 6 for the network. So 1, 2, 3, 4, 5, 6. And the dividing line here, and we have 2 bits on here for the hosts. So we need to find out the magic number, which is from the left of the dividing line. That's going to be 1, 2, 4. So the next increment for our subnet is going to be 192.168.2, and then 112 plus 4, which is going to be 116. That's for our next subnet. So we just need to find out the new subnet mask, which will be 255, 255, 255, and then add all the values here, which is 128, 64, 32, 16, 8, 4. This will give us 252. So we've borrowed 6 bits for the network portion. So adding on from the 24, this is going to be 24 plus 6, which is 30. So that is the subnet mask for this here. And so since the requirements for the next 2 will be the same, it's going to be the same subnet mask. We just need to find out the new increments. So since we said we're going to be borrowing the same amount, the next increment will be 4 again. So the next subnet will be 192.168.2.116 plus 4, which is going to be 120. And so for our last subnet, it will be up until 192.168.2.124. This is where the next subnet can begin. And so from 124 till 255 is the remaining IP addresses from the IP address 192.168.2.0. The subnet masks for these 3 will all be the same, and the prefix will be the same as well. That's 30 and 30. And so the subnet mask for these 3 will be the following. So that brings us to the end of this video, where we've gone through this example on how to approach these sort of questions for different host requirements for a network. And I hope you guys enjoyed this video. Make sure you like and subscribe. Again, if you have any suggestions for any topics that you'd like me to cover, make sure you leave it down in the comments. Thank you.